So 9-7, as you know, as I mentioned, this and 9-6 are very closely related. In 9-6, we're trying to find the angles. In here, we're going to try and find the segments. For example, we had a very similar picture in 9-6. We were trying to find that inside angle there. We added the two angles together and divided by 2, right? That's basically what we did. And so AC, how would you describe AC? Well, you could call it a chord, or based on what we called it on Friday, it would be a secant, okay? How about dB? We could call it a chord, or again, based on what we did on Friday, it would again be called a secant, quite possibly. So now I'm not going to be given, for example, I would give you that information, or maybe that's what you would have gotten on the other day, but now we're going to take a look and try and find what the segments are. And in this particular example, you could read what they say there, but what they're really telling you to do is take little piece times little piece. And for example, if I told you this was 4 and that was 4, and then I told you, say, this was 2 and that was x, x is something you should be able to figure out, because what you do, you see that the red segment there has kind of been cut partially. Maybe in half, maybe not. Obviously, in this case, was it cut in half if it's 4 and 4? Yeah. And if you take little piece times little piece, you would take, if you do the red, it'd be 4 times 4 would be little piece times little piece. And then over here, was the green one cut in half like the red one based on what we see? Probably not. But what you do is take little piece, which is 2, times the other little piece, which is x, is what we called it here. Is that something you can solve for? Yes, what is 4 times 4? Obviously, 16 equals 2x, divide by 2, x is 8. Okay, so what some people like to do off to the side once we've done that is actually say, take little piece times little piece. Did I ever use whole thing? For example, did I use the red being 8 total? No. Did I use that the green one was 10 total? Did we do that? No. Okay. So somewhere off to the side on this one, you need to take notes of what's going to help you remember that. Because remember, your test is coming up soon. So if they're ever inside like that, little piece times little piece. Okay. Yes?
What if they don't, like, 4 and 4, what if they don't show you 2 or even the whole thing?
Okay, very good question. For example, the question was, what if they give you 4 and 4, and then for some reason they say, this thing's 10? Great question. What I would do then is I would make one of the two x, one of the two pieces. So if this is x, what do we say for EC then? 10 minus x. Very good. And that's going to get much more complicated, but that's also going to take us to the quadratic formula that we learned the other day. So that's actually the type of problem where that's going to come up. She was just thinking ahead, that's all it was. She saw that coming, and that actually is a great question. What do you do there? And so you still solve it the same. Excellent question. So this one right here, are they hitting each other inside? So is it going to be little piece times little piece like we just did? No. Whenever they hit outside, what I like to say is to take outside piece, and I'll put it like this. So take outside piece times whole thing. And what is whole thing? Okay. And for the red one, let's say it's 6 and we'll leave it like that. Yeah, well, actually, no, we'll do it like this. X. Okay. So the rule here is if they hit each other outside is to take outside piece times whole thing whenever that happens. And what is, for the green, what is the outside piece? The outside the circle piece, 8. Times whole thing, the whole green one is 8t. How about for the red one? The outside the circle piece is 6, and the whole thing happens to be x. All right, so really, that's a pretty straightforward one, right? Well, how about 8 times 18? Does anybody have? Yep. I had to do that one in my head quick. 6x. How are we going to solve that? 6. I do believe that is 24. So over here, the whole thing would be then 24. At that point, could I ask you, say, for a y that was just in there for the inside piece? Yeah, it would just be 18, right? I mean, you could do that. And this is another part where, with the question we had before, again, I could ask you for just that inside piece, right? If I were you, if all is asked is for that inside piece, say TS, why not just find the whole thing? Because isn't that easier on these? Just find the whole thing and then go ahead and go in there. But again, here's where they can make this much more complicated. Give you that and say, you know, put an X here or something like that, and then that creates a problem. Because then this outside piece is 24 minus whatever X is, and then things can get more complicated. I'm just trying to give you the general idea. So far, what do we say? If they hit inside, just take the two little pieces that are made for each one and multiply. If they hit outside, you're supposed to take the piece that's actually outside the circle times the whole thing of that segment. Okay? So they hit each other where? Outside. I truly believe this to be the same thing. At least that's how I look at it. And for example, let's say I told you this was 10, and perhaps this was a 5. And we'll call this X. I just like X. Oh, I'll try D next? Okay. So here's how I look at it. Again, the book considers this a completely other option. I don't. They hit each other outside. So what I say is take the outside piece of the segment times the whole thing. I still look at it that way. So let's do the KL. How much of KL is outside the circle? And then if you take it times the whole thing, it's 10. The book says this is a completely different option, but I'm still taking the outside piece times the whole thing, aren't I? It's nothing different. So look at it that way. Now, well, how about the outside piece for LN? 5 times the whole thing, which means, nope, not 5x. X plus 5 or 5 plus x is the whole thing. So x plus 5. Now, you may think this is another instance where we're going to have to use the quadratic formula, but you're only going to use quadratic when you get x squared. Am I going to take x times x in this problem anywhere? No. Now, is that going to happen on some of these? Yes, I'm going to be straightforward with you. It is. But how about the left side here is 100? You actually have a choice of dividing by that 5 if you want, but I think most of you are probably going to distribute it. Is that correct? Okay. So it's 5 times x is, well, 5x plus 25. All right? Dividing by 5 right now is an option, but I think most of you are been programmed or have been programmed to do this. And so 75 equals 5x. You've been programmed to divide last, if at all possible. X is 15. Okay, so then this piece in here is 15. And then keep in mind, could I technically then ask you for all of Ln? I could. Could just ask you for Mn, any of that's possible. In this problem, are we guaranteed that Mn is, say, a diameter? No? Could it be? Might be. We don't know. And truly, if it is the center at this point, you know, I could ask you for the circumference of the circle in this problem after you solved all that. So keep in mind, sometimes just finding these answers is not the whole thing. Do you have any questions? So once again, the book considers there to be more options than I think. I think there's really 2 options. Either they hit inside or they hit outside. That's how I look at it. All right. Well, where do they hit? Okay. So you are to take the outside piece of the segment times the whole thing. So let's do the blue segment first. The outside piece is 5. And the most common error for people to do is to say it's 5 times 15. It is not 5 times 15 because it's the outside piece of the segment, or the piece that's outside, times the whole thing, which is 20. Okay, so let's do the red segment. The red segment, it's outside, so we take the outside piece of the segment, which is x, times the whole thing, which is, again, so we're taking x times x, now careful, X squared. Very good. Now, once again, some of you are thinking that we're going to have to use quadratic formula on this one, but we actually do not. You could. It would be a little bit of extra work on your part, because 5 times 20 is 100 equals x squared. The term that's missing here is that x term that we had when we did quadratic last week. And seeing it's not there, it actually makes the problem a lot easier. Because right now, all we have to do is get rid of that square, and we've got x all by itself. Yeah, house of I is kind of how most of you were taught that. So you take the square root, so the house of I, so x equals, now in strict algebra, it's positive and negative 10. But then you have to take a look at your problem and decide if both of them make sense. Can I put a positive 10 in there and have it make sense? Yes. Can I put a negative 10 in there and have it make sense? No. Yeah, if there was more information there, maybe. So don't always think the negatives are just not going to work. So here basically x would be 10. Any questions on that one? Anybody?